How can we use dimensions to verify the physical validity of an equation? Now let's take the quantities x, which means displacement, v sub I, which means initial velocity, a uniform acceleration, and t, the time taken for the object to travel with an acceleration a, starting with the initial velocity v sub I, and making a displacement x. So traditionally, we know that this equation is given as x is equal to v sub I times t plus 1/2 a t squared. We are assuming that the initial displacement is 0. It doesn't matter here. We can keep on changing the equation. It doesn't matter as long as they are consistent. The dimensionality of x is just length because it's displacement L raised to 1. So direction does not seem to matter. Why? Not only that is length or distance of dimensionality L raised to 1, so is the displacement of dimensionality L raised to 1, because they're still measured in meters. V sub I is the of dimensionality L raised to 1 divided by t raised to 1, because velocity is displacement over time, and we already know the dimensionalities of those two quantities. T, as we know, is t raised to 1. Acceleration. Now we know acceleration to be equal to change in velocity over change in time, and change in velocity is equal to change in displacement over change in time. Once again, we see change does not change dimensions. That means the dimensions of v are the same as dimensions of delta v, because whether you subtract $5 from $10, you still have $5. The dimensionality does not change, the units do not change. So it will be, if velocity is L raised to 1 divided by t raised to 1, acceleration will be L raised to 1 divided by t raised to not negative 2, t raised to 2. Now, the question is, it's similar to the units what we use. Quite often it's easier to write dimensionality using the units. Now, what does this mean? Let's find the dimensionality of v sub I times t. This term will have dimensionality L raised to 1 divided by t raised to 1 times dimensionality of time, which is t raised to 1. So what are we saying here is that this quantity is nothing else but dimensionality of v sub I times dimensionality of t. So we can multiply quantities of two different dimensions. Though we cannot add or subtract quantities of different dimensions, we cannot equate quantities of different dimensions, but we can multiply quantities of different dimensions. So this would give me just L raised to 1. Aha! That means dimensionality of the first term is same as the dimensionality of x. Now let us see what is the dimensionality of 1/2 a times t squared. The number 1/2 does not have any dimensions. So let us say I have dimensionality of 1/2 times dimensionality of a times dimensionality of t squared. Sorry, t squared. Now, that dimensionality has got no dimensions. While we know the dimensionalities of a and t squared, because there is no unit for that half there, or let's say a unit which is got in length, mass, and time. So we're going to write this as dimensionality of this one will be L raised to 1 divided by t raised to 2, and dimensionality of t raised to 2 will be dimensionality of t raised to 2. And that would mean I will be left with dimensionality of t squared and t squared cancels off, or let's say divide each other. It becomes dimensionality, its dimensionality becomes L raised to 1. Aha, the dimensionality of this is also L raised to 1. Dimensionality of this one is L raised to 1, and dimensionality of this one is also L raised to 1. That means this equation at least is physically not incorrect. What possible errors could be there? These multiplicative constants may not be 1 and 1/2. We do not know whether it is subtracting or adding. Or we do not know if there are more number of terms of the same dimensionality, L raised to 1. But for those unknown situations, as it is, it does not represent a physical quantity or an equation which is unphysical. It is physical, but it could be inadequate or erroneous in terms of the value it calculates. So there are three basic things which we will write. Quantities, dimensions must be same to add, subtract, and equate. Dimensions need not be same to multiply. Dimensions cannot provide proportionality constants. Or verify between addition and subtraction. Or verify missing or extra terms, extra addends. So this gives us a way of using dimensionality to identify the validity of an equation and possibly sometimes even guess a particular nature of the equation.